In this video, we're going to talk about static types. Now, you may have wondered why this line of code that we've written often, how does it actually work? I mean, we never actually create an instance of the console class. So how is it that I can call a method called writeLine on that class? Well, the reason is because the console class, when Microsoft originally built it, was adorned with the static keyword. Okay? So now I'm going to make a differentiation between instance classes like we've been building. The auto class, the engine class, the assembly robot class, the truck class. They're all instance classes. In other words, I need to create a new instance of that class in order to work with its methods and properties. But you can take any class, even an instance class, and you can add a method to it that's called a static method that does not require you to create an instance of that class in order to use it. In other words, it can be used like a utility method. It can be used across any, it can be used anywhere in your code without having to create an instance of that class. And so it provides a utility. I can also then take that same class, for example, the assembly robot, and we'll take that class in a moment. And I can make that class static, which means all the methods and properties have to be defined as static methods and properties. All right, so static classes allow you to use only one instance, or rather there is no instance. It's a singleton in a sense. The class becomes the instance. In the case of the console application, logically, you shouldn't be able to create multiple console windows for a single application. Therefore, to eliminate that possibility, you work with a single static class that represents the Windows console. Okay? So why would you ever want to define a method as static within your own custom classes, or create your entire classes to be static classes? Well, you would do this again to create a globally available resource. In other words, you want to create a class that'll be used like a utility that can be used anywhere without requiring an instance to be created, much like we did with the system.console class, as we've been using it just about everywhere in code, right? So also, there's another reason why you might want to do that, and if you're working with a single instance of a domain object, much like the console window, I'm going to use the assembly robot as an example here in a moment. And there can only be one assembly robot that makes sense within our application, then it might make sense to make it static. So let's go ahead and do that. Let's use our assembly robot here. And what I want to do is, let's delete that, and start out with a public static. I added the static keyword, auto assemble car. So it's going to, again, take in some values and return a car, and I don't want to have to create an instance of the assembly robot in order to call its assemble car method. So what I'll do here, you can see that I've got at least one engine available, what I'm going to do, and we'll comment this out as well. Let's just call assembly robot dot, and even though I haven't created an instance of the assembly robot class, I'm still able to see the static method assemble car in IntelliSense. Okay, so that's a good sign. So string, we'll go with our previous example, Prius. And the engine type, I believe V4 was the engine type that we've defined up here, right? So then let's go auto my car equals assembly robot. All right. And so now we can do my car dot whatever. It is an instance class, an instance of the class called my car. But with assembly robot, I didn't need to do that. Okay. So what we can also do is apply the same thought process to a property. Now, if I were to define a property in the assembly robot like this, and let's just call it all right, so I've given the assembly robot a name, maybe so we can find it out on the shop floor, okay? Assuming that this represents a real instance of a robot in the real world. So semantically, that's different then. I would have to create an instance. So if I go assembly robot dot, I don't see it because it's not a static property. I have to create an instance of it in order to give it a name because it represents the name property only makes sense in the context of the fact that there might be multiple instances of these robots laying around, and I need to find the right one. What's your name versus what's your name, okay? So I would have to create a new instance like this. Assembly robot, my robot equals new robot, and then my robot.name equals Bob. Okay. But if I were to change this to a public static method, you can see that I'm going to get an error here that an object reference is required for the non-static field method or property. So there's a little bit more effort that we're going to have to go to make this work, right? So we might have to do this as well. And that'll take care of the problem. So we had to make the private member variable, the private field, static as well, because again, logically, it's just representing one value. Now it works a little bit differently. I can't, as you can see, I have a red squiggly line when I'm trying to get to the name property of the robot. That name no longer belongs to each individual instance. Now I can still get at that name by doing something like this. Assembly robot.name equals Bob. But now that belongs to the class itself, not to an instance of the class. So, you know, its utility, its usefulness, a little bit, you know, maybe you won't see that as much as you see it used here. It kind of works like a constant value that's available across your entire application. So not used as often as the static method, unless you're trying to, again, work with one instance. Like, for example, in the console window, we did something like, what was it again here? The console color, right? Or back color, or foreground color. There we go. And in that sense, again, console is only referencing a single logical container, a console window. So setting its property there makes sense, okay? But if we were to have multiple console windows, you wouldn't make it a static property. You would make it an instance. Same is true with all of its methods as well. Okay. So now, if we wanted to make a static class and require that all members and all methods and properties were indeed static as well, and I'm just going to remove the static keyword from our property and field we just created. I'm just going to create static class. And when I do this, I'm going to hit F6 on my keyboard here. I'm going to get some errors because you cannot declare instance members in a static class. All right, so I'd have to add that back in order for this to work. Okay, so now from this point on, all of our methods and properties must be static in order for it to satisfy the requirement of the static class. Okay, so I'd recommend that you not overuse the keyword static. When you need a globally available set of methods or properties, it makes sense to combine them into a static class. But when you need multiple instances, obviously that wouldn't work. And since our application only needs a single instance of the assembly robot, okay, maybe it makes sense in that particular case. And perhaps since we need to use it in various places in our code, okay, then maybe it makes sense. Maybe it's a good candidate to make it a static method. Maybe not. It really depends on what you're trying to accomplish within your code. But again, if you're not 100% sure why you're using the keyword static, I would stay away from it. And we can talk more about the use of static and designing applications to take advantage of static when we get more into topics about best practices around designing and building applications. I just wanted to introduce the notion of the difference between an instance class and a static class, and how you can use the static keyword to define static methods on an instance class or a static class. The same is true with properties, or using the static keyword on a class, which would mean all of its properties and methods must be defined as static as well. Okay, so that concludes this video. Hopefully you can see that distinction between the two. We'll see you in the next video. Thank you.